Good morning, everyone. I am Revati, Assistant Professor from the Department of Computer Science and Engineering, Government College of Engineering in Singipati. Now I'm going to explain the concept of implementation techniques in DBMS fourth unit. So first concept is RAID. That is, RAID is a redundant array of independent disk. That is a RAID. So what does this? Originally redundant array of inexpensive disk is a way of storing a same data in different places on multiple hard disks to protect the data in the case of disk failure. So basically this concept is come for disk failure. So in the database consistent level cannot be changed and we have to recover the data safely. So for that we are storing the data into more than one hard disk. So how we are storing this data into a multiple places, that is called the technique and levels of RAID. So disk organization is a technique that manage a large number of disks, providing a view of single disk of high capacity and high speed of by using multiple disks in a parallel, and high reliability by storing a data redundantly so that data can be recovered even if a disk failure. So mainly the RAID concept is developed only for disk failure, and it recover the data easily. Next one is motivation of RAID. So just an additional memory in the form of cache. Like a cache, we can have an additional memory for our database, and it is stored in different places in different concept. So it can improve the system performance. So in the RAID, we can use an array of disks which operates independently. Since there are many disks, multiple IO requests can be handled in parallel if the data required is on separated disks. So a single IO operation can be handled in parallel if the data required is distributed across the multiple disk. So here the single IO operation can be handled in different disk. That is a motivation. Next one is benefit of RAID. So the data loss can be very dangerous for an organization. So this is very important to care the data. So for that we are using a RAID. So RAID technology prevent the data loss due to the disk failure, and RAID technology can be implemented in the hardware or software. So servers make use of RAID technology. Next one is there are 7 levels, that is level 0 to 6 for storing the data into multiple disks to recover the data from the disk failure. So first one is level 0. So RAID level 0. So this is a basic level. It divides the data into block unit and writes them across a number of disks. So there is one data is divided into more than one type, and that is stored in different types of disk, like that. Yeah, as a data is placed across multiple disks, it is called a data stripping. This technique is called data stripping. The advantage of distributing data over disk is that different IO requests are pending for different block data. Then there is a possibility that the request blocks can be on a different disk. If it is on a different disk, means we can give the permission to next disk, so we can avoid the waiting stages. Like that, the pending cannot be for any all disk. Like that, we can reduce the time wastage, and there is no parity checking of data. Here there is no parity bit, and so if the data is in one drive gets corrupted, that all the data would be lost. So there is a disadvantage of RAID level 0. This level 0 does not support a data recovery. Spanning is another term that is used for level 0, because logical disk will span all the physical disk drives. So RAID 0 implementation requires at least minimum of 2 disks. So here this is an example for disk RAID level 0. So G21, 20 to 31 is a data. So these data are shared between four types of disk 0 to disk 3. So here 20 and disk 0 only have 20, 24, 28, and another values are stored in disk 1, and second one and third one, like that. The totally 12 data that is defined declared in a three types of disk. That is a first level. So data are stripped. Next one is level 0, level 1. So it is also called disk mirroring. So this configuration consists of at least two drives that duplicate the storage of data. So that is no stripping. So here we are not distributing the data to other disk. We are copy the data and store into the next disk. So here we are improving a performance. The read performance is improved since either a disk can be read at the same time. The write operation is also same as a single disk storage. So each write is carried out of both the disks. So if you are performing write operation, means we can perform in the both disk also. So mirroring also we can perform the write operation. If one disk in the pair fail, the disk will available in the other. So it give the recovery, full recovery for our data. So data loss would be occur only if a disk fail and its mirror data also fails because the system is repaired. Probability of combined event is very small. Next one is this is an example diagram for level 1. This is an example diagram. Disk 0 and disk 1. So here A, B, C is a first content, and the same content is copied into disk 1. And here disk 2 having D, E, F, the same content is copied into D3. So here the values are copied into other disk. Next, level 2, bit level stripping. This configuration uses a stripping across a disk with some disk storing error correcting and checking and correcting information. That is, I'd have another disk, separate disk to store the error checking and correcting. So what are the errors in this disk? So this is very cost and complex structure. So for every disk, we have to calculate the error correcting ECC value. So it requires additional drive for error detection. So there is no advantage for over RAID 2, and there is no longer used. This is now not used. So we are go for next level, third. Level 3, byte level stripping. So here the RAID 3 consists of dedicated parity. So that is, we have a parity information that is stored in each disk selection, that is right into dedicated parity drive. So for that we have a for every disk we have a dedicated parity drive. For example, so here A and B disk 0 and 1 having a 2 value. For these two there is a separate disk, there is disk 2 having a parity of A and B. So that is a byte level stripping. So in the case of disk failure, drive failure, the parity drive is accessed and the data is reconstructed from the remaining devices. So once a failed device is replaced, the missing data can be restored on the new drive. So in this level, the data can be transferred in bulk, thus high speed data transmission is possible. So for using a parity bit, we can use a high speed. It requires an additional drive for parity, so that is a disadvantages, and it gives a slow performance for operating a small sized files. So this is example for C and D. We have a new drive, parity drive, P of C and D, like that, E and F. So next level is block interleaved parity, that is level 4. So when writing a data block, in level 3 we are using a bit level and this is a block level. So the block means number of bits, more number of bits are used in the block. That is a difference. When writing a data block, corresponding block of parity bits using also computed and returned to the parity disk. So to find the value of damaged block, compute the XOR of bits from the corresponding bits. So that is from the parity, it calculate the XOR operation of error correcting code. How it is calculated means the data bits are, the values are 0, the parity values are 0, 0, 0, 0, 1, like that. There is a even number of 1 means the parity value is 0, and the odd number of 1 means it having a parity value is 1. So here this is an example. So first C1, C2, C3, C4, the parity value, the only one is added, that is odd number of 1, so it have the value is 1, and even number of 1, that is 1, C3 and C4 having a value 1, so it having an odd number of 1, so it stored the value as 0. So that is it XOR the values. So this is a disk values are stored in this disk 0, 1, 2. Here the parity value, always maintaining the parity drive P0, P1, P2. So this parity is related with this even parity or odd parity. Like that, we have to calculate the errors. We have to reconstruct the data from the failure. Next one is level 5. So RAID 5 uses a stripping as well as the parity for redundancy. So we have to get the data from the parity, and we have store the data into a multiple disk, that is a stripping. So it is well suited for heavy read and low write operation. So for both condition we can use this level 5. So both block interleaved distribute parity, partition data and parity among all n plus 1 disk rather than storing a n disk of parity plus 1. So that is n data that is stored in a n plus 1 disk, that is including a parity bit. This level is cost is effective and high performance. It have a high performance. In this level, parity is distributed across a disk on the array. So distributed means the parity is distributed in the all the levels. It make the random performance better. So what is a parity distributed means? So here this is a parity, that is first level it is stored in disk 4, next it is stored in disk 3, and next it is stored in disk 2, next is stored in disk 1, and last it's stored in a disk 0. So any one of the disk failure means from the parity value, parity 0, we can get the data from disk 4, and parity 1 it reconstructs the data from disk 3. So parity 3 it reconstructs the data of disk 1. Like that, we can distribute the parity to all the levels, all the disks, so we can easily get the reconstruct the data. So it is distributing data, stripping, and the parity is also used. That is a level 5. Next is level 6. This technique is similar to RAID 5, but including a second parity. We are using a second parity also scheme that distributed across the drive in the array. So the same drive it uses a parity. The use of additional parity allows the array to continue the function even if two disk files simultaneously. So if any two disk failure means we can access data by using a parity, two parities. So here the extra protection comes at a cost, so it give a high cost. P plus Q redundancy scheme similar to level 5 but stores extra redundant information to guard against a multiple disk failures. So it is 100% disk capability, as half is used for mirroring. So it contains very limited scalability. It have only limited scalability. So this is an example. The parity is distributed across more than one. So it is P0, P1, P2. So again we have here P3. Like that, the parity is distributed, but the values are again it have another parity A0, B0, C0. So this is a first disk parity. Second one BA1, B2, A1, B1, C1. This is a second parity. So like that, the data is distributed, and then the parity is also distributed, and then again second parity is included in the disk. So this is having a 100% recovery of data. So this is a RAID levels. of redundant arrays. Thank you.